Hello, welcome back to another lecture on the course on speech signal processing. So if you recall, I have started talking about statistical approaches, talked about something called the Gaussian mixture model, and then came to the idea of Markovian chains and then hidden Markov model. So I'll review this again because it's an important topic for another few minutes, whatever we did in the last class or last couple of classes. Okay. So if you remember, we were talking specifically about the weather because that is something that we can relate to, right? We see it happening every day, so that is something that we can relate to, and so understand the hidden Markov or the Markovian chain in terms of the weather, right? So in the weather, if you look at the numbers that we were interested, there was something called the transition probability. So in a Markovian chain, right, what it means is that we are talking about a sequence of events, okay, and an event depends on what happened on it can depend on its history, right? But in a first order Markovian chain, we say that on an event that occurs, depends only on the previous day's event or previous time instance event, because we're talking about sequential data. So here we're talking about as a specifically in our cases always as a sequence in time. Okay, so it's a sequence of events occurring in time. Maybe the time unit can be a day, an hour, a minute, whatever you want, but normally we do something of that kind. And so any event depends on what happened just before it and not on the entire history or 3 events before or 2 events before and so on. Only so it's the first order that it depends only on the previous event. Okay, so we can observe historical data and just find out the number of times a particular event followed another event, right? And then the total number of such observations, and then you will get a probabilistic idea, right? So the probability. So in the case of sunny, weather, in our examples we assume there are only 3 weather conditions: sunny, cloudy, and rainy, right? So with these 3 weather conditions, right, we can ask, because it's a first order process, we only look at what happened before, right, one day before, or what happened the previous day and so on. So we in this case we are assuming there are only 3 weather conditions. These represent in our terminology the states. Okay, so the weather condition, states model the weather condition. So states model the weather condition, right? So each state represents a particular weather condition. So state 1, let's say, belongs is whenever it is in state 1, it is basically in the sunny case. In state 2 it is the cloudy, and state 3 in the rainy, right? That's what we mean by this. Okay, so this cloudy or sunny. Okay, so these are the 3 states we are interested in. Okay, then we introduce this concept of a transition matrix, right? So what I did was I looked at the historical data, right, over last 10 years, 20 years, 100 years, whatever it is. And so if yesterday is or today is sunny, right? So today is sunny or cloudy or rainy, what is the probability of tomorrow being sunny or cloudy or rainy? Okay, that is the question that we asked, and that we looked at the historical data. Let's say I found historically, sunny, cloudy, sunny, cloudy, sunny, cloudy, rainy, cloudy, rainy, sunny, something like that. And the number of times that given the previous day was sunny, how often did the cloudy occur, right? Given the number of times that something was sunny, cloudy, how often did the rainy occur, right? So we calculated, counted these things, divided by the total number of observations, and so we got this probability that it's 0.5 here, 0.3 here, 0.35 here, and 0.15 here. Okay, so given that today is sunny, remember we are only assuming that it can be in one of the 3 weather conditions, right? So tomorrow can either be sunny or cloudy or rainy. So it can be only in one of these 3. Therefore, given today is sunny, it can be this total probability I have to add up to 1. It has to be in one of these 3 conditions, right? So the total probability along a row will always add up to 1, right? Similarly, historical data I found out, and found whenever it's cloudy, right, the chances of sunny is about 0.3, okay, and where cloudy being cloudy itself is let's say 0.45 or something, okay, and this was or let's say this is 0.25 and this is 0.3, some reasonable kind of thing, right? And so this is 0.25, it's too much, 2 and 3.5 or something like that, okay. So then when it is rainy, it is only 0.05 chances of sunny next day maybe. It continues to be cloudy for a long period of time, so it continues to be cloudy 0.4 times of the time, right? And this is 0.55 or something, okay. So this is what we call as transition matrix, and so this is telling the probability historically what happened, right? Given today was sunny, the chances of tomorrow being sunny is 0.5, the chances of tomorrow being cloudy is 0.35, the chances of tomorrow being rainy is 0.15. Similarly, if today happened to be rainy, the chances of tomorrow being sunny is only 5%, tomorrow being cloudy is 40%, and tomorrow being rainy is 55%, okay. So if it rains, there is more chance the next day also it will rain, okay, something like this. So this is all historical observations. We can either use this, or we can also represent it in terms of these state diagrams basically. So remember I said these circles represent the three weather conditions. So this is the sunny, the rainy, cloudy and the rainy, right? And so the chances, so given something is sunny, it can go to sunny 0.5% of the time. So it starts from here and goes out, right? Given it's sunny, it goes to cloudy like this, okay, that is 0.35, and given it is sunny, it goes to rainy 0.15% of the time. 0.15% of the time, right? And the converse. So given it's cloudy, it can go to sunny 0.2 here, right? Because this is what I observed here. Given cloudy, the next day sunny is 0.2. So that's what this is representing. Given cloudy, for it to be cloudy again is 0.45. So this is 0.45. It happens to be cloudy again. And given cloudy, given going to rainy is about 0.35. Similarly, rainy to sunny is 0.05. So rainy to sunny is 0.05. Okay. Rainy to cloudy is 0.4. Rainy to cloudy, rainy to, this is starting from rainy, next day being cloudy is 0.4. Okay. And rainy to rainy itself is, here rainy to rainy itself is 0.55. Okay. So we can represent the transition matrix in terms of this diagram, in terms of the nodes and arcs, right, where the nodes or the states represent a weather condition and the arcs or the edges basically tell you the probability that given it is in the state, what is the probability it will go to the next state or the other state with certain percentage, with certain probability, right. Now, this diagram or this matrix is very useful to expand it in terms of weather conditions. So, if I ask, given something is cloudy, so I am telling you this today is cloudy. Cloudy, okay. So, tomorrow, so today's tomorrow can be only one of these three states, right? It can be sunny, so that's one state, or it can be cloudy, or it can be rainy, right. So these are the three states that are there. Normally we draw the states along the y-axis vertically. So if I have this diagram, this we can represent this in this form also, right. So we can say, given something is cloudy, the chances of it going to be sunny the next day is 0.2 from this diagram, here, or from this matrix I can say it is 0.2 here, right, and therefore I will put this as 0.2, correct. Similarly, given it's cloudy, for it to go to cloudy is cloudy to cloudy is 0.45, right, this guy here 0.45, or cloudy to cloudy here is 0.45, and so this will become 0.45, and here it is going to be what? Given it is rainy, right? It can be, it can again be rain, given it's cloudy, right? For it to be rainy, E is given by this, given it's cloudy, for it to be rainy is 0.35 in this diagram, or cloudy to rainy is this diagram 0.35, right? So this is 0.35, right? Now if I want to go the next day, so day after tomorrow, right? So this is the day after tomorrow, right? Again, day after tomorrow can be only in one of these three conditions. What are the three conditions? It can be sunny, or it can be cloudy, or it can be rainy, right? Correct? Now, what happens is, if I had reached sunny here, right? So now this is now becomes the new observed, and this is the day after tomorrow. This is the previous day, this is the next day, right? Remember, only the previous day will depend, not on previous 2 days or something. So this guy can go to sunny how often? So this can go to sunny how often? So sunny to sunny is what is the chances of that? That is about 50% chance. For it to go from sunny to cloudy here, it is 0.35 chance, right? So it is 0.35 chance, correct? And for it to go from sunny to rainy, either I can look here. So sunny to rainy is 0.15, or I can look from sunny to rainy here in the transition diagram, both the same, 0.15. So this will be 0.15, correct? Correct. Now, if I happen to be in the cloudy condition on tomorrow, right, and then day after tomorrow I want to see what will happen, then what will happen? I can go cloudy to sunny, right? So cloudy to sunny is what? Cloudy to sunny is this guy 0.2, or I can draw here cloudy to sunny is 0.2. So cloudy to sunny is 0.2, right? And cloudy to cloudy is what? Cloudy to cloudy is 0.45, or here also I can look, it's 0.45, right? Cloudy to cloudy is 0.45, and cloudy to rainy, if I look at this diagram, so cloudy to rainy is 0.35, or cloudy to rainy is also here also, it has to be same information, right? It's only one is in matrix form, the other is in the. Then from rainy, again I can see the chances of it going to sunny is only 0.05. So rainy to sunny is 0.05, right? So this is 0.05. Rainy to cloudy is 0.4. Rainy to cloudy is 0.4, and so this is 0.4. And rainy to rainy, it's a self loop, right? 0.55 or 0.55 here, right? 0.55 here. So this will become 0.55, right? So this is, now we are talking in terms of, this is what is called a path, okay? So now I'm opening up as the days progress, right? I'm now getting some kind of a, why do we say path? So what, given that today is cloudy, so when I start asking question, given today is cloudy, what is probability of next 2 days being sunny and sunny, that is being continue to be sunny on both the days, right? So that is basically means today is cloudy, that I know, today is already cloudy, I know. Now I am asking what is the probability that the next 2 days, so today means tomorrow, so this is tomorrow and day after, right? So tomorrow being sunny and day after being sunny, that's the question that I am asking. So I know that tomorrow there's a 0.2 chance that it will be sunny, and for the other day also it's a joint probability, right? So the other day also being sunny is 0.5, so it will become probability of sunny given cloudy into probability of sunny given sunny, which is 0.2 into 0.5. This is what we are going to do. This is 0.1 probability that the weather condition given today is sunny and sunny. So this is like a path, right? That's why we are saying this path, basically these arcs or the edges are telling you the probability. So you can keep multiplying those probabilities, and that is what will be the probability of that path occurring given today is cloudy. Or I can ask, given today is cloudy, what is probability of tomorrow being cloudy and day after being rainy, day after being rainy. Okay. So now that means I am today cloudy, I have to go tomorrow to cloudy again, day after to rainy. So I have to take cloudy, today is cloudy, I have to go to cloudy tomorrow, and then cloudy to rainy day after tomorrow, right? Which is this path 0.45 multiplied by 0.35, which will be probability of cloudy given cloudy into probability of rainy given cloudy. Probability of cloudy given cloudy is 0.45. Probability of rainy given cloudy is 0.35. So 0.45 multiplied by 0.35. I think this is 4 3 is 12, 1125 or something like that, right? So 0.1125. Okay. So something like this will come. Okay. So 1325, I think. It's either, I mean, some trick is there. I think it's 1325 or 1125. Okay. So so now I can keep evaluating. So we evaluated two paths. One path was through this guy. One path was like this, and the other path came like this and this. So basically, whenever I'm going through the path, I'm evaluating the multiplying by the corresponding probability, right? That's all I'm doing. So now I can answer a question given today's cloudy. What is the best forecast for the next 2 days, right? So what will I do? So I can now answer questions like this. Given today is cloudy, what it means is, what is the most likely couple of states that I can go? What are the two weather conditions that can happen given today is cloudy, right? So there I have to be careful. I am looking for the best, which means the total probability should always be largest. That is the most likely thing to happen, right? So whichever is a highly likely event, that should highest probability of this events, joint events occurring, that is the most probable one. So that's the one I should choose. So if you look at it, I did sunny that gave me a probability of 0.1. Similarly, I did cloudy rainy, I think, yeah, cloudy rainy, that gave me some other point. Like that I have to go through so many paths, right? And how many paths are there? So here there were 3, right? There are 3 paths here. Again I can go here 3 into I can have any one of these 3 conditions, right? And again I can have any one of these 3 conditions. So in all there will be 9 different paths that I can take, right? So I can take, see, one path is this, or 2 path, or 3 path, right? Or second, that is 4. So 1. So if you want, I'll 1 path, right? Then 2 path, like coming here, and 3 path, right? Those 3 are finished. Then 4th path, then fifth path, like that you can see 9 paths will come, right. So 3 into 3, 9 paths will come. Among all of this, so I evaluated for 2, I have to evaluate for all the 9 paths and choose the one. So evaluate all 9 paths, choose the one with the highest probability. Correct? And so that is the basic idea. That's all we are doing. Okay. So that this is basically the idea of Markovian chain, and this means if I have 5 paths, right? So I have to evaluate. So if I have 3 states, right, and 5 days forecast I want. So day 1, day 2, day 3, day 4, day 5, right? If I want that, right? So this is a states, and along this is time. So this will be again 3 raised to the power of 5, which is 243 paths I have to evaluate. And this is where there is an efficient algorithm that is basically, this can be efficiently done using the Viterbi algorithm. Okay, so that is the basic idea. So this algorithm basically makes we are still calculating all those 243 paths. Okay, or if I have whatever number of paths that I need to evaluate this properly. Okay, and this it can be, how is it going to do efficiently? What it's trying to do is that let me again draw this condition, right. So I have drawn this very nicely. Okay, so now what I do is to be I'll use this figure itself, so because it makes my job a little easier for you to understand what I'm trying to do, and then I will show you how Viterbi is so efficient. Okay, so essentially what you're going to do is, let me look at this particular, that day after tomorrow, the second day, right. So I'm already in cloudy, that is today. Tomorrow is D1 and day after tomorrow is D2, right. That's how we are going to go about, right. So if I want to ask what is the probability that I am here, right, on day 2, what is the probability that the day 2 weather will be sunny? Okay, now how, what is the, so I am asking what is the probability that, so I want to be in this state on day 2, right. How can I reach this state on day 2? I can come from the today to day 1 tomorrow through sunny, and then again continue to sunny and reach here. So this is one path, right, and the probability of that path is what? 0.2 into 0.5, right, that is the first path, right. Or I can also do another way to come to sunny. What is the other way? I can say cloudy to cloudy, right, and then I from cloudy to sunny also I can come, right. That is also possible, right. So the probability of coming to sunny through this path, through the cloudy to cloudy followed by cloudy to sunny, is given by what? 0.45 multiplied by 0.2. Okay, 0.45 multiplied by 0.2. Or I can reach this sunny stage from going from cloudy to rainy, which is 0.35, and then from rainy I can go to sunny, which is 0.05. So this probability is 0.35 multiplied by 0.05. So there are 3 ways that I could have arrived at this particular sunny state, right. Now I want to see the one which is the best path, which is the most likely that could have led to me coming here. the most likely one is the one that had the highest probability among all these three, correct? So, let us say the highest among these three happens to be this guy, which is 0.1, let us say, okay. That is the highest chance for me to come. So, for me to be here, the best path is this path and that probability is 0.1. Okay, all the others, if I come this route, it is less likely, right? If I come through this route, it is less likely, or if I come through this route, it is less likely. So, this is the best route for me to reach Sunny here, and that best route is 0.1. Okay. Now, similarly, if I ask what is the best way that I could have arrived at cloudy on day 2. If I want to arrive at cloudy on day 2, now what do I do? So, this is my, I can again come from cloudy to sunny and then sunny to cloudy with a 0.35 chance, right? This is 0.35. So, this is 0.2 multiplied by 0.35. Okay. Then we are taking the other probability is this guy followed by this guy. So, 0.45 and I think cloudy to cloudy is what? Cloudy to cloudy is also 0.45. Okay. So, cloudy to cloudy is 0.45. Yeah, sorry. This is cloudy to cloudy and same thing has to happen here. No? Sorry. Yeah. So, this is 0.45 into 0.45. Okay. And the third probability is this guy 0.35 cloudy to rainy, and then rainy can go back to cloudy with a 0.4 chance. This is 0.4. So, I will erase it and make it proper. This is 0.4. Correct. So, this is 0.3 multiplied by 0.4. So, 0.3 multiplied by 0.4, right. Among all of this, this is the most, so maximum of these three. So, it says if I have to be in the cloudy state on day 2, the best path is this guy which is coming from cloudy and cloudy. So, this is the best path to come here. Okay. So, therefore, among all, remember whenever I want to come here, there are many paths that I can come to, right. But I am trying to find already the best path. So, if I have to be in cloudy, it has a probability of 0.45 into 0.45, which is basically I think 1725 or something, 0.1725. Okay. And the path for that is basically this path. That is what it is trying to say. Okay. So, already I know what is the best way to come to sunny and the probability is always 1.1 to come there. I know what is the best way to come to cloudy and that is also 0.25. Similarly, for rainy, I can do the same thing. So, it will be this path followed by the, sorry, first let me start with the sunny, this path followed by the 0.15 path to come to rainy. So, it will be 0.2 multiplied by 0.15, okay, or 0.45 multiplied by 0.35 or 0.35 multiplied by 0.55. That's how we do. Okay. And this one, among all of this, you will see that this is the most likely probability. Okay. And that means coming from cloudy to rainy and rainy to rainy. Okay. So, this is the best path to come here. Okay. So, this is the best path to come here. And so, already the max of all of this, max is equal to 0.35 into 0.55. That is the max that you can have, right.